We often think that the journey to the moon is humanity's greatest achievement, but for astronauts, the real challenge lies in returning home. Reaching the moon does not mean you are safe. In space, even the smallest error can become a one-way ticket. On Earth, if you get lost, you can turn back. But in space, there are no roads, no signs, and nowhere to stop. To return to Earth, the spacecraft must not only fly in the right direction, but also at the correct speed, at the right time, and at the precise re-entry angle. If it is too slow, it may fail to escape the moon's gravity. If it is too fast, it could drift endlessly into the void. This journey is not like a normal round trip. It is like throwing an arrow into the darkness and catching it back in your own hand. It sounds simple: go, land and return. But in reality, every stage is a life or death equation that must be solved perfectly. In space, there are no repair stations, no rescue teams. Everything must be prepared in advance. Fuel, oxygen, electricity, water, and the very chance of survival. And the most terrifying truth is this: the journey home does not begin when leaving the moon. It was decided from the very moment the spacecraft left Earth. A small miscalculation in mass, fuel, or trajectory may still allow astronauts to reach the moon, but they may never see Earth again. The real question is not just how to get there, but how to leave and return to where you started. Earth does not stand still waiting. It rotates. It moves through space, and the spacecraft must aim for a moving target from hundreds of thousands of kilometers away. That is why the Apollo missions succeeded. Not just because of powerful engines, but because humans calculated every second of a journey that allowed no mistakes. The journey to the moon is a battle against gravity, but the journey back is a battle against error, temperature, velocity, and time itself. Even entering Earth's atmosphere is a terrifying gamble. A slight misalignment could cause the spacecraft to burn up or bounce back into space. From the moment of launch to the moment of safe splashdown, the entire mission is a chain of calculations carrying human lives within it. That is what makes the moon story extraordinary. Humanity did not just dare to go far, we dared to believe we could find our way back. The journey begins with leaving Earth, a planet that holds everything with an invisible yet immense gravitational force. To escape it, the spacecraft must reach an almost unimaginable speed, over 11 kilometers per second. Slower than that, it falls back. Fast enough and it begins its escape, but reaching that speed requires enormous energy, more than any machine humanity had ever built. That is why rockets are mostly fuel. During launch, most of the rocket's mass is not the spacecraft, but the fuel needed to escape Earth. To solve this, humans invented multi-stage rockets. As each stage runs out of fuel, it detaches and falls away, making the spacecraft lighter and faster. Piece by piece, the rocket sheds itself, like stepping stones pushing humanity closer to space. Even then, the spacecraft is still being pulled back by Earth every second. To truly escape, it must keep accelerating until it reaches escape velocity. Only then is it no longer bound to its home planet. But escaping Earth does not mean flying straight to the moon. Instead, the spacecraft follows a carefully calculated curved trajectory, like throwing a stone so hard that it never falls, but keeps sliding around the planet. From that orbit, it continues its journey toward the moon. If this first step is wrong, the entire mission cannot be corrected. In space, there is no reset button, only consequences. Once in deep space, the spacecraft does not travel along a road. It moves through emptiness. There are no lines, no signs, no sounds. The journey becomes a problem of physics and time. The spacecraft is not flying straight, it is constantly falling, just precisely enough not to hit anything. A tiny error in speed or angle can grow into hundreds or thousands of kilometers over time. That is why navigation systems must be incredibly precise. Even engine burns lasting only a few seconds can decide the fate of the entire mission. As the spacecraft approaches the moon, another challenge begins. It must slow down at exactly the right moment to be captured by the moon's gravity. Too fast and it flies past. Too slow and the trajectory collapses. Entering lunar orbit is essential before landing. Every calculation must be nearly perfect. A few seconds too early or too late can change everything. Landing is even more dangerous. The moon has no atmosphere to slow the spacecraft down. All deceleration must come from engines. Landing is not like touching down. It is like hanging a spacecraft on a pillar of fire. The surface is uneven, full of craters and rocks. Dust rises and blocks visibility. Astronauts must rely on instruments, not just their eyes. Even after landing, the mission is far from over. The spacecraft becomes the only ticket home. If the ascent engine fails, there is no backup. Launching from the moon is one of the most fragile moments in the mission. The small ascent module must lift off and rendezvous with the command module orbiting above. In space, meeting again requires near-perfect precision. Once docked, the journey home begins, but it is not simply turning around. The spacecraft must calculate a trajectory to intercept Earth, a moving target using limited fuel. Re-entry is the final test. Enter too steeply, and the spacecraft burns. Too shallow, and it skips back into space. The angle must be almost perfect. As it enters the atmosphere, extreme heat builds up, not from friction, but from compressed air forming plasma hotter than 1,000 degrees. The heat shield protects the crew by slowly burning away. For a few minutes, communication is lost. Then, as the spacecraft slows, signals return. Finally, parachutes deploy, and after hundreds of thousands of kilometers, the mission ends in the ocean. But beyond all the physics and calculations, the moon journey is something deeply human. It is not just about technology, it is about curiosity. Why would a fragile species leave its home to reach something so distant? Because humans have always wanted to know what lies beyond the horizon. The moon is not just a destination, it is a question humanity has carried throughout history. And perhaps the greatest achievement is not reaching the moon, but understanding the universe enough to come back and tell the story. From Earth to the moon and back again, this is not just the journey of a spacecraft. It is the journey of humanity.